So in this video, I'm going to show you how to use an analysis of variance. And Anova, or analysis of variance, is another hypothesis test that we can use to look at the relationship between two variables. And in this case, this would be when we have a continuous outcome or dependent variable and a categorical a categorical predictor or independent variable. And so in this case, let's say that the research question that we're looking at is about the whether there are differences in math achievement by urbanicity. So urbanicity meaning the sort of geography or locale that the Census Bureau uses. That has four categories. So there's urban, suburban, town, and rural. So we're interested in whether there are differences across those. So in this case, we have to take these variables and start to assign them into categories of dependent and independent variable. So I just said that our dependent variable or our outcome is math score, and our independent variable or predictor is urbanicity or location. And so what we could do, some people might want to look at this just with a conditional means table. So we would use our locale or urbanicity as different rows. And then we can just put the math score in a column of that table. Oops, sorry, used the wrong command. So this is going to tell us the mean of the math score for urban schools in an urban setting, schools in a suburban setting, schools in a town, and schools in a rural setting. And so as you can see, yes, descriptively there are differences. But this doesn't tell us anything about whether these differences are significant. And so what we can do with an Anova is it lets us look and see whether these differences, whether there are significant differences. And something that's important here when we're choosing Anova is that the answer it's going to give us is really just whether there are significant differences across all the different levels or categories of locale or urbanicity, meaning sort of like are the differences in average that we see here, can we say that those are consistent with a random variation or not? That's essentially what it's getting at. So what we can do is now we take this and let's run an Anova. So really simple. The command to do that is Anova. And then first up, we want to put our dependent variable, our outcome. And then we want to put in our predictor or our independent variable. So in this case, it's locale. And then we hit enter. And now we get an Anova table that tells us about how much variation is explained by this locale variable, and then how much is left, how much variation in our outcome is unexplained. And then we get our F statistic. I mean, the main things that you'll be looking at are your F statistic and then the p-value over here on the right. And so we want to make sure that we're reading all of that for locale, our independent variable. So in this case, locale is a significant predictor of math score. So meaning that there are significant differences in math achievement across urbanicity. And then if you want, you can look at the fit statistic right here. We're looking at the R-squared, so about 0.9% of the variation in math score is explained by urbanicity. Importantly, that's all that this Anova tells us. Is there a significant difference across all of these levels? It doesn't tell us anything about specific differences. So this Anova isn't going to tell us anything about the difference between rural and suburban. Descriptively, there's a difference. We don't know based on this Anova, or we don't know from this Anova whether that difference is significant or not. Same thing with when you're talking about city or urban versus suburban. There's a difference here. This Anova does not tell us whether that difference is significant or not. If you are specifically interested in that, what you would need to do is break this variable up into several different, you could break it into several different binary variables and do a bunch of t-tests, or alternatively, you could use simple regression and specify, I'm not going to show you how to do that here, but you could specify a base category. So let's say that you wanted to, compare everything to urban schools. You can do that within the regression framework and compare, suburban schools to urban schools, town to urban schools, and rural to urban schools. So if that is more central to your research question, the important thing here is, what is your research question? You don't always need the most sophisticated analysis to answer a research question. You just need to make sure that the way that you interpret the research, or the way that you interpret the results, are consistent with the method that you selected and the research question that you're working on. So that is how we can look at a bivariate relationship where our outcome or our dependent variable is continuous and our independent variable is categorical. We did that using Anova, and that's all there is to it.